Good evening, everybody. I'm happy to open this evening's special lecture within our third multidisciplinary conference dedicated this time to time. In our previous conferences, we hosted very special guests. The historian, Professor Pierre Nora, a member of the Académie Française. Later on, we hosted Professor Antonio Damasio, whose scientific interests are neuroscience, psychology, philosophy. And this year, we are delighted to have another very special guest, Joel Cohen, Professor of Earth and Environmental Sciences at Columbia University and head of the Laboratory of Population at the Rockefeller University. For me, bearing the same name is a special honor. But the important thing is that apart from his brilliant scholarly achievements, about which my dear friend Kobe Klein will elaborate, Joel Cohen exemplifies the scholar that these conferences are delighted to expose. He is the ultimate multidisciplinary scholar. Professor Cohen's research centers on populations. This requires deep knowledge in demography, ecology, population genetics, epidemiology, social organization of human and non-human populations, and mathematics. As we all know, division into disciplines is a human invention designated to enable us to grasp and to impart knowledge more easily. Yet, life and nature are all mixed up with no disciplinary boundaries. Not all of us can examine social and natural phenomena from various disciplines, and those who are able to do it enrich us and enable us to understand the world from richer, deeper viewpoints. So, Professor Cohen, we are delighted to have you here, and we look forward to hearing you on lifetime, the limits and meanings of age. But before that, I call upon my dear friend, Professor Kobe Klein, professor at the Weizmann Institute, who served as head of physical chemistry at Oxford University, the recipient of the Tribologic Gold Medal, world's highest award in friction research, an Academy member who will present our guest. But before that, I would like to thank the dedicated team of the academia, Kochi, Yaakov, and our Director General, Yossi, yes? Galia, our Director General, who else is here? Chevy, for their utmost dedication to the Academy and to the events here. Thank you very much, and please, Kobe.
It's a pleasure to introduce Professor Joel Cohen. Joel, we've known Joel for about 44 years. We just worked it out since I was a PhD student and he was a visiting scientist at Cambridge long ago. That's in the 70s. Joel, Nili introduced him, his position and so on. He did a PhD in Harvard, and then he liked it so much that he did another PhD in Harvard. So he's actually got two PhDs. His first one consisted of watching groups of school children, and then he went to Africa and watched groups of monkeys, grouping and ungrouping, and timed them and measured the variations in the groups and in the individuals. And this fed in to his model, the mathematical model, which was part of his PhD. He then, since 1973, has been a population, since 1975 he's been a professor at Rockefeller, and since 1995 also at Columbia, and he's got other appointments elsewhere. I won't go through his entire CV, otherwise we'd spend a fair chunk of our time on this. He has received many awards. He's been recognized in many ways. He's received a Guggenheim Fellowship, a MacArthur Fellowship. These are the Genius Fellowships. He received the Tyler Prize for Environmental Achievements and many other prizes. He's a member of the US National Academy of Sciences as well as other academies. He has published well over 400 papers and book chapters, and he has written, in addition, 14 books. I won't mention them all. They deal with a whole range of topics, and Professor Nili Cohen alluded to the range of his interests. One book that I do know about, since we have a copy, is perhaps his best known book. It's called How Many People Can the Earth Support? And it's a weighty book, it's a heavy book, both from the point of view of the contents and its physical weight. And in contrast, he's also written a book, a very light book. It's called Absolute Zero Gravity. And it's a joke, it's a book of mathematical jokes, the sort of things, how many physicists does it take to change a light bulb, that sort of thing. And that book is a nice counterpoint to this one, and indeed shows what I know Joel to have, which is a wonderful sense of humor. He's written, in addition to his books, he's written for the popular press, he's written for the New York Times, for Scientific American, for the New York Review of Books, and he has a sort of TED Talk-like presentation, which has been viewed 170,000 times already on YouTube, about his introduction to demography. Anyway, Joel, we're absolutely delighted to have you lecture to us this evening.
Thank you, Professor Nili Cohen. Thank you, Jacob, Professor Klein. Thanks to you for being here. Can you hear me, Jacob, in the back? Okay? Okay. The problem with writing a joke book and some serious books is that my colleagues can't tell which is which. So that's a problem. I'd like to thank the members of the Academy staff who have worked so hard and patiently to arrange everything so that this can be a successful visit. And it's been a wonderful visit. I had a tour of Jerusalem this morning that showed me parts of the old city that I've never imagined seeing. And there weren't any other tourists there, just the tour guide and myself, in cellars and rooftops, and it's a fantastic city. I came to Israel the first time in 1966, which is a while ago. And it's a new country since then. It's really changed unbelievably. And so I congratulate you on the economic transformation, and I wish you success in the social transformations that are continuing. It's an amazing country. And thanks to some very old friends who have come here today, as well as to all of you. Well, my title is Lifetime. And speaking of time, I'm going to talk very briefly about life in time, and then time in life. So this recapitulates some of the information and adds a little bit that we heard yesterday in the wonderful series of talks all day yesterday. The Earth is about 4.5 billion years old. So Earth scientists refer to that as a giga-annum, GA. The G stands for 10 to the 9th years, and A is annum. So the earliest life came shortly after the origin of the Earth, about 3.8 billion years ago. Multicellular life only became possible after the great oxygenation event about 2.5 billion years ago. Before that, the Earth's atmosphere was mainly methane, and when the green plants evolved, they polluted the atmosphere terribly by adding oxygen to it. The consequence of the oxygen was that there was enough energy available to support multicellular life. And that began all the trouble that has led to us, which continues. The oldest fossils with a well-defined nucleus, eukaryotic cells, are about 1.5 billion years ago. Sex came along around 1.1 billion years ago. Before then, all reproduction was asexual, just dividing and replicating. The arthropods appeared at the end of the Precambrian 500 million years ago, and now I'm zooming faster and faster. The earliest great apes, 14 million years ago. Homo, that's our genus, in the Pleistocene about 2.5 million years ago. Modern humans about 200, or maybe sometimes people say 300, but 200 to 300,000 years ago. And agriculture, the support for everything in our life today, essentially the origin of cities, the origin of our modern life, is only 0.00001. That's 10,000 years ago. 0.00001 billion years. This slide reminds me of Psalm 8. Since I am in the city of David, I remind you of what King David asked God in Psalm 8. He says, "What is man that you are mindful of him? Mortal man, that you should take note of him?" And I think it's a very good question, because here we are, our way of life is 0.00001 of the history of life, and yet we seem to have this involvement. So that's life in time, and now I want to turn to time in life. And here are the 2 points that I want to make. First, the demographic record gives no evidence that human longevity will soon reach a ceiling. That's a carefully phrased statement. I'm not saying we can live forever. I'm not saying humans will ever live forever. But I am saying we are nowhere near reaching a ceiling. We have no evidence for the existence of a ceiling to human longevity yet. Okay? And 2, I want to tell you how demographers and people who study populations are thinking about time and age, because the way of thinking has changed dramatically in the last half century. How we define and measure old and old age greatly affects our image of the present and the future, and many alternative definitions are now being explored, and I'm going to show you some of those. Now, this is the greatest scientific paper published in the United States. It's called The Onion, and I have to read you the first paragraph in case you can't read it. World Health Organization officials expressed disappointment Sunday over the group's finding that, despite the enormous efforts of doctors, rescue workers, and other medical professionals worldwide, the global death rate remains at 100%. So the point here is we are all going to die. No argument. What interests us is when, and demographic death rates involve time. So it's time that's the key ingredient in understanding our progress in survival and mortality and well-being. There's a distinction that we make between aging and senescence. Aging means increase in time since birth. I age at about 1 second per second. And guess what? So do you. We all do, okay? Senescence means either an increased risk of death per person per time, that's mortality, fertility, a decreased fecundity or fertility per person per time, or decreased functions. Geez, I can't remember things that I used to remember. Or I can't run as fast as I used to, my knees won't take it. Or et cetera, et cetera. Senescence is not a universal feature of all life. And there's a recently published book on the evolution of senescence that points out that it has arisen independently in different clades of life, but it's not universal. And it's not even universal among sexually reproducing higher organisms. So the question is, why did senescence evolve? And this is an area of research for which we don't have answers. I'm going to focus on time, aging, and senescence in humans. And there is a whole other topic on the comparative biology of aging. I'll give you one finding from that. The maximum duration of life seems to vary in proportion to the 1/4 power of body mass across thousands of species, for plants, for animals, mammals, birds, etc. Why that's true, that's debated. Among mammals who have brains, most of us included, it varies more tightly according to brain size than it does to pure body mass. Body mass is variable, brain mass is less variable, and so that's a better predictor of longevity. But I'm not going to talk about the comparative biology. I want to give you 4 concepts of chronological age. So I'm not talking about senescence now at all, just chronological age. And I want to give you 4 variations on that theme depending on where it's applied. To one person, or to a cohort population, or to a period population, or to a longitudinal population. And we're going to go over each of those. So this is a graph of time, chronological time, called the period. And I'm going to use the letter P for the point in chronological time. Any point here is a point P. And this is age. And one demographic finding that I'm happy to report to you is that most people are born at age 0. Age 0, okay? So I'm born in some year here, and I'm at age 0. A year passes, and lo and behold, I'm a year older. Another year passes, I'm another year older. I come to the end of my life, and that's my death point, D. And my lifespan is from birth to death. It's my age at death, or it's the difference between the year in which I died and the year in which I was born. This is trivial, obvious, okay? For an individual, we have an unambiguous, well-defined notion of chronological age. That's one. Let's use that idea. This is a graph of the oldest well-documented living person in the world as a function of time. So in 1956, the oldest person in the world was 108 and a little bit more. And that person, time is going this way, age is going that way. This is an application of the graph on the previous slide. That person lived for 2 years and just short of the 110th birthday died. At that point, the oldest living person in the world was 107. That person was the oldest person in the world, died. A brief period here, so and so on. Okay? Does this make sense? Okay. So these are the oldest living people in the world based on well-documented sources, not pretend stories, real sources. This is Jeanne Calment, a woman in France, who died at the age of 123, 124. She was the longest living, oldest person. Okay? And if you look at this, you see a kind of upward drift. And that's a puzzle. What is that? Well, it could be 2 things. This is an unpublished slide, and so you're now in the middle of research. The population of the world here was a little over 2.5 billion. And the population of the world over here was 7 billion. 7.5. So the world's population roughly tripled. It has tripled in my lifetime. So the question is, are we sampling, do we have a larger sample so the extreme values could be bigger, or was there improvement in survival at the older ages? And the answer is both. And the question is, how much? What's the relative contribution of those factors? And I don't know the answer to that yet. I'll come back to that in about 10 years and we can have another conversation. Okay, so this is for individuals. Suppose you take now all the people born in a year. Let's say that this is 1 year. That's a birth cohort, or 5 years, or 10 years. You can define a birth cohort any way you want, but let's take it's a year. As time passes, everybody who's still alive in that birth cohort ages by 1 year. But the number of people is not constant because people are dying. And so the birth cohort gradually fades out. So I can think of a curve over this birth cohort. It starts out at 100% and gradually, with mortality, fades down to nothing instead of 1 to 0, okay? So we want to describe the shape of that survival curve. And we do that, let's see if I can make this work. Yes. But I pushed it the wrong way. Okay. So this is 100% up there, and this is 0%. It's the proportion surviving. And this is called a survival curve. Okay? Everybody dies by the age of 130, let's say, to take account of Jean Calment. And you now need summary statistics for this. How do you summarize this in a convenient way? One way is to take the average length of life. And it turns out it's a mathematical fact. For those who like calculus, you do integration by parts. It's the integral under this curve. The area of this region under the curve gives you exactly the average length of life. And the way to see it intuitively is, you think of a life as a lifeline. It starts here at age 0 and goes across until it bumps into that. And there's a whole stack of lifelines here, and they're shorter and shorter as you go up. The first to die end up there, the last to die end up here. The average of all those lines is just the average, it's the area under the curve. Anyway, another measure is the median life length. When the number of survivors, or the fraction, reaches a half, that's the age at which half the people have died. That's the median life length. Half lived longer, half died before then. So that's how you measure survival in a cohort population. A period population is the people who are alive now. For example, the people in this room constitute a period population. We're all born in many different years, but we're all alive here now. How do you measure the age of the period population? Well, you could just take the average age, or you could take the median age, that's obvious. But suppose you want the whole survival curve. We don't know what's going to happen out there. So we invent a model called a synthetic cohort. And here's what we do. We assume we know about the survival of infants during this year. The people who are 5 to 10, we pretend that their survival, that these people will have the survival in the future of the survival of the people who are now at the older ages. So I'm going to say this in words here. Calculations assume that when today's newborns reach age 10, they will have the survival rate of today's 10-year-olds. When they reach age 11, they will have the survival rate of today's 11-year-olds. So we make a synthetic cohort so that we can calculate that survival curve for a period population. And I want to show you some historical examples of what period survival curves look like. And this is England, where the data exist, from 1541 to 1991. This is really a colossal piece of work. And the survival curve, so look, we start with 1,000 people. That's the equivalent of 100%, okay? 1,000 people. Survival curve falls extremely rapidly. By 1 year, we've lost 20%. That means 20% of children die within the first year. The median life length is about 30 years and drops off very, very quickly. As time passes, these curves go up and sometimes come down when there are famines or plagues. But in general, after the Industrial Revolution, the drift is upward. And 1991 is the highest one, and it comes down here. Median life length moved from 30 to 80 in those 450 years. And life expectancy, that's average life length, it rose and fell from 34 years to 82 years. We estimate that in the Roman Empire, life expectancy was somewhere between 18 and 30 years, average life length, okay? By 1541, it had risen in England only to about 34 years. Very slow progress. But within the last 4.5 centuries, it's more than doubled. Very dramatic change in life survival. So my colleagues and friends, Eupen and Vopel, said, what is the best practice in the world in terms of life length? They took all the credible data from all countries with good mortality data in 1840. And they looked at the one where women, females, had the longest period life expectancy. Period means at that time using a synthetic cohort. It was 46 years in Sweden in 1840. They did the same thing in 1860. Look at all the countries in the world, find the country with the highest life expectancy. That year, it was Australia. And it had risen a couple of years. Do the same thing in 1940 and 2000. Okay? The countries that fall in the best practice place changed over time. But over these 140 years, the life expectancy of the best practice country rose by roughly 1/4 of a year per year. The average life length over this time rose by 2.5 years per decade, 24.3 years per century. And there's no evidence of curving over. For individual countries, yes. But for the best practice country, which is now Japan, and has been for quite a while, the life expectancy just goes marching up 1/4 of a year per year. That's an amazing finding and suggests that there isn't an imminent ceiling for the best practice. During this time, people have repeatedly said there's an upper limit to human life expectancy. So in 1930, when was this published? 1930, Dublin, who was an actuary for a metropolitan life insurance company, said the maximum life length is 65. That's the ceiling. And he wasn't aware that in that year, the data already showed that the life expectancy had exceeded 65 in New Zealand non-Maori, okay? Dublin and Latka said the same thing. Dublin again. The United Nations, Jean Bourgeois Pichat in France, World Bank. Every time these people come out with a projection that this is the limit, the life expectancy keeps marching past, okay? If life expectancy were close to a maximum, then the increase in record expectation of life should be slowing. It is not. Now, is that just because we're using expectation of life? What about the other measures? Well, this is the expectation of life, the mean. The median also keeps increasing, and the mode is the age at which most adult people die. It's where the biggest bump is in the death curve. That also keeps marching up. So it's not, and this is for females, but females and males, there might be a difference. But there isn't a difference. There's a difference only in location and rate, but not a difference in the pattern of continuous increase. What about extreme survival? In the United States, the age to which 1 in 100,000 survive, according to this survival curve, went from 105 up to 110. The age at which 1 in 100 survives for males increased from 104.4 to 109.8, from 105 to 112. This trend runs counter to the widely held belief that the age attained by the oldest survivors in the population has risen little if at all. That's our social security system. Okay. This is for the general population. What about for special subclasses of the population? So people have studied the survival of intellectual elites, like the Royal Society of the UK and the Russian Academy of Sciences. And I think it would be a very interesting, if you have enough data, enough people in the Israel Academy, to try a comparative analysis. There are demographers at Hebrew University who can do this very easily, and if you give them the data, it would be interesting to see what the situation is here. Let me tell you the story where we have the data for sure. This is the best practice from the Human Mortality Database, which is what all the previous stuff was based on, this black line. Now, if you look at the Royal Society of England, where we look at the life expectancy at age 50. Among people who reach age 50, how many years of life do they have left on average? 10, 20, 30, 36, okay? So 36 means that the age of death would be 86, 50 plus 36, because we're looking at remaining years of life at age 50. And for the members of the Royal Society, it is consistently, except here, above the best practice in the world. Okay? For the Russian Academy of Science, it goes up and down with respect to the world best practice. And for a long time, under the Soviet Union, was below the world best practice, even though they are an elite within Russia. And it just catches up with the world best practice over there. These are period life tables and cohort life tables. These are people followed forward through time, and the contrasts are sharper over there. So, in England and Wales, the general population had life expectancy at age 50 years, same graph as in the last slide. This is 1970 to 2005. Went like that, increasing. So England and Wales had the same life expectancy as people with higher education in Russia, here. The bottom social class in England and Wales had lower life expectancy, and the upper social class had higher life expectancy, equal to that of the Russian Academy of Sciences. And the Royal Society in England had even the highest. The general population in Russia, meanwhile, was declining. There's an advantage in survival to education and social status. And you see it here. I'm not talking about my own research on this, which comes to a similar conclusion by a more circuitous route. But, you have to try everything. So, the first point is the demographic record gives no evidence that human longevity will soon reach a ceiling. Okay? Does anybody want to ask a question at this point before I go on to the next part? Yes, sir. Speak loudly.
Yeah, why do you call the ones, the country that has the best record, best practice?
That's a very good question. The question was, why do I call the country that has the best record the best practice? And there's no good reason. It's because my colleagues used that when in that article that first investigated this question. But we don't know that the practices are the best. All we can judge is the outcome. That's a very good question. And I would prefer simply maximal life expectancy, which is descriptive and not theoretical. So I agree with your point. Yes, sir.
Just curious.
Loud, please.
Just curious, but what are we looking at in this picture?
This is, I was in Tibet. What's in the picture? This is Lhasa, Tibet.
Okay. Just curious.
Thank you. Any other question? Yes, sir.
Do you have those graphs about the Jewish people?
I don't. But they may exist, and there's a very good group in demography here in Jerusalem, the Hebrew University. They may have such information, but I don't. Yes, sir.
With the introduction of antibiotics at World War II introduced a huge difference in infant mortality, and so in some way, it is not very credible to judge over this before this period.
That's a very interesting question. So the question was, the introduction of antibiotics before and during World War II had a huge, reduced infant mortality dramatically. So it's not fair to compare before and after antibiotics. I let the data answer your question. There are continuous innovations all along. Antibiotics was very important, but the introduction of anti-tuberculosis drugs, the introduction of hand washing, the introduction of clean water supply in London, all were technological innovations that had tremendous effects. What we are looking at is the envelope of many different effects, and that's a straight line. The data are not showing a discontinuity at the introduction of antibiotics. The age at which the improvement in survival occurs has changed dramatically. And there we get to the kinds of things that you're talking about. Up until around 1950, most of the improvements in survival were happening among children. And since then, most of the improvements of survival in the advanced industrial countries have been among older ages. But that's another lecture and another course, okay? So that's an interesting question. One more question and then I better go on. In the back, the lady in the far back, she had her hand up first. Excuse me.
What year was this lady, 130 year, died?
When did she die?
What year?
97.
What year was this 130-year-old lady died?
1997.
Okay, thank you, 1997. There's the answer. I don't remember, but the answer. 1997 was the answer that I heard. So we can check this out. Thank you. Okay. Let's go on, and then we can ask more questions, okay? So we covered point one. Point two, how we define and measure old and old age greatly affects our image of the present and the future. So there are at least 5 ways that people think about aging in a population and in individuals. One is the medical functional point of view. How strong is my grip? How well can I breathe? How fast can I walk? Do I have to walk very slowly? Can I just go right across? Biomarkers. How long are my telomeres? How are my DNA methylation sites? There's a whole bunch of fancy biomedical markers that are called biomarkers. Psychological function. I can't remember how old the lady was who died. But, you know, you can make a quantitative test. You say 10 words to me and you ask me to repeat them, okay? Or fluency. You ask me to name as many fruits as I can, okay? And those things change with time. What brain diseases do I have? And we heard a wonderful talk yesterday about Alzheimer's and Parkinson's diseases. Then there are the economic changes. My labor force participation, my savings, my level of education, human capital. And finally, there's the demographic indicators based on time. And I'm going to focus mainly on time, but they are connected with all these others, and I'm going to make some of those connections. We've spoken about average age. We've spoken about median age. That's the age where half are above and half are below. We can look at the percent less than 15 as an indicator of the age of a population. This is a concept that does not apply to an individual. You know, either you're less than 15 or you're not. But a percentage describes a population, or the percent over 65. And there are many such. So I want to show you what we think is coming in terms of demographic aging. This is 1950. We are here. This is science fiction, but very plausible science fiction. This is what we demographers call projections of the future. And it's pretty good, but it will be wrong if we have a nuclear war, or if we have an influenza pandemic that kills everybody, or if we have some other kind of, you know, a comet strike. But if business as usual goes on, this is pretty good, okay? And I can say that based on the last 100 years of population projections, because we've been able to, we started making good population projections in 1895, and we have 120 years of experience. And they're getting better. So here's the big story. The number of children, 0 to 4, reached a peak around 1990. This is the billions of people in that age group. It reached a peak of about 600 million, and it's going to be flat to the end of the century. No more children. Young people, 0 to 14, the recruits for your armies around the world. It's going to reach a peak about now or soon, and flat for the end of the century. The number of grandparents, and many of you, the lucky ones at least. 900 million age 60 plus in 2015. That's 9/10 of a billion. Another 500 million in the next 12, 15 years. 2.1 billion and up. So there are going to be many more grandparents than grandchildren. This worries a lot of people. And the question is, should we be worried? And I don't know, but I'm going to tell you alternatives to being worried.
Sorry, who's the guy?
He's an Algerian sculptor. I was in Algeria, and this guy was sitting out there carving wood, and he looked very happy. And I said, do you mind if I take your picture? He said, no. So I took his picture.
So why is the discrepancy between the 0 to 4 and 0 to 14? It should have been maybe displaced by 10 years or so.
This number includes these plus everybody aged 5 to 9.
Yeah, but why 5 to 9 increased so much? Should have been displaced by 10 years.
You're exactly right. And look, you see this bump here? That's this bump here. Actually, it's an echo a little bit later, but there's some mortality between. But you're exactly right. Okay? These people are the survivors of growth earlier. So that's the cohort problem. Okay?
But the lines should have been parallel to each other.
Not exactly, because there are differences in survival. They should be lagged. They should be lagged. But then there are differences in survival. And the survival is not homogeneous across countries, so it's a weighted average of numbers in different places. Another way to look at the same picture is, if you set each population age group equal to 1 in the year 2000, what's going to happen? Relative population change. So the 0 to 9, now we have another age group. 0 to 9 is the red line. 10 to 24, now that's college and military age, leveling off. 25 to 59, this is the working nominal economic activity age. And 60 plus is the blue line. Globally, the number of older persons is growing faster than the numbers of people in any younger age group. And they're growing faster in urban areas than in rural areas. And the growth rate, which is 5 minutes? 10 minutes. Thank you, Jacob. Okay. Is highest in the less developed regions because the fraction of older people, the baseline, is higher already in the developed regions. So most of the increase in the elderly will occur in the countries that are poorest. Standard & Poor's is a rating agency in the United States that does credit ratings of governments and countries and companies all over the world. No other force is likely to shape the future of national economic health, public finances, and policy making like the irreversible rate at which the world's population is aging. So now I turn to Pirkei Avot, Ethics of the Fathers. And Rabbi Eliezer would say, repent one day before your death. Asked his disciples, does a man know on which day he will die? Said he to them, since no man can know, he should repent today, for perhaps tomorrow he will die. So Rabbi Eliezer had the idea, let's look into the future rather than into the past. But he didn't have the technology to do that. Population science has now discovered the technology for estimating what fraction, and with precision, what fraction of the population will die in 5 years. What fraction will die in 10 years? We don't know about individuals, but we know what fraction of the population will die in any number of years in the future, and I'm going to show you how you do that. So the question raised by a sociologist at Princeton named Norman Ryder is, should we call a person old if he has 65 years behind him, or should we call a person old if he has less than 15 years left to live? Or 10 years, or some amount, you name it, but let's say 15. So do we want to look at remaining life expectancy less, that means I have less than 15 years to go, or I have X years behind me? So remaining life expectancy is the area under this curve divided by the height at that age X, okay? That's how we know what remaining life expectancy is, and there's an equation for it, which I'm going to skip. Let's look at the practical consequences. In the USA, 70 is the new 60. In 1935, people of both sexes aged 60 to 64 had remaining life expectancy of 15.7 years. In 2010, people aged 70 to 74 had remaining life expectancy of 15.79 years. 70 is the new 60. There are t-shirts you can buy. These are a slight exaggeration, but the point is substantively correct. What does this mean for Israel? Is it good for the Jews, right? What does it mean for Israel? This is the proportion of the population age 65 plus. If you look at old as 65 plus, Israel is going to have a great increase in aging. This is the proportion of the population with remaining life expectancy less than 15 years. It is almost flat. It means that old is drifting higher and higher from that perspective. And the question is how to engage people like you, mentally active, intellectually curious, able to get out and engage in life. How can you engage people so that they are a happy and productive part of the society? That's the problem. It's not the problem of aging, it's the problem of how do you engage people in life. Israel, while important, is about 1/1000th of the world's population. So what's happening in the rest of the world? It looks something like this for the world as a whole. Tremendous increase in age 65 plus, much smaller increase in people with remaining life expectancy less than 15. Now the world is a heterogeneous place, as I was trying to say earlier, and 7 countries have half the world's population. So let's look at them. And you tell me, what are the 7 countries, the 7 biggest countries that have half the world's population? China, India, Brazil, Indonesia, correct? US is correct? No, Russia is not on the list. Did somebody say Brazil? Yes, okay, Brazil. 2 more. Pakistan. Nigeria. You got it. Perfect. A+ to this crew. Whoops, wrong way. Sorry. Here are the thank you. This is a very well-informed audience. I'm really impressed. China, India, US, Indonesia, Brazil, Pakistan, Nigeria. So we're going to look at those countries. And I'm going to do this quickly, so you better watch fast. China, India, USA, Indonesia, Brazil, Pakistan, Nigeria. This is the only one where death rates are so high that the fraction of people who will die within 15 years, remaining life expectancy less than 15, is higher than the fraction of people who make it to age 65. And only late in the century, according to these projections, do they cross over. So that's an indicator of a disadvantaged country, a really sadly disadvantaged country. But let's look at a couple of other countries because they are economically and socially important. Germany. People talk about the German catastrophe of aging. It depends on what you mean by age. Japan. Okay, so let's try another. The UN is exploring another measure of aging. The traditional old age dependency ratio was invented by economists. Persons age 65 plus divided by persons age 20 to 64. Okay, that's OADR, old age dependency ratio. These 2 guys, an economist at Stony Brook in New York and a Russian mathematician, working together in Austria, obviously. The prospective old age dependency ratio. Persons above age X, the age is that's closest to having remaining life expectancy equal to 15 years. So I don't know what that age is, but it's somewhere. So we take the people who are above that age and we divide it by the people who are below that age back to age 20. That's the prospective. How much? Okay, I'm getting to the conclusion. The traditional old age dependency ratio is going up. This is historical part up to where the data are. And the prospective is going down. Things are getting better. So your view of the present and past depends on your definition of what the problem is. I have to ask you a question. What is the difference between mathematics and sex?
This is from your book, right?
This is from ancient, I discovered it in some scrolls that I excavated in a cave. It's a very old joke. The difference is, it's actually the question is, why is mathematics like sex? And the answer is, it's okay to talk about it, but you really shouldn't do it in public. So, but I'm going to do it in public. Mathematics, that is. How do you calculate the percent of a population with X years left to live? And this is a relatively recent discovery in demography. In a population with a survival curve, that's that curve that we were talking about, where X is the age and L of X is what fraction we have left. And a proportion Px of age X, the proportion of the population with X years left to live, we're going to call that Tx. You take the proportion of the population aged Y. What's their chance of living another X years? Well, it's L of Y, this age, plus X, divided by how many we have now. That's the proportion that survive. And then their probability of dying at that age, X years ahead, Y plus X. And you integrate that over all ages Y that can contribute. So how many people what fraction is going to die in 10 years? Well, some people aged 100 will die in 10 years. We calculate how many. Some people aged 99 are going to die in 10 years. Some people aged 98 are going to die in 10 years. Some people aged 2 are going to die in 10 years. Some people aged 1 are going to die in 10 years, and some babies are going to die in 10 years. We add up all those numbers, that's this integral, okay? That's all the mathematics we are going to do in public. A French demographer who was teaching in Cameroon discovered a beautiful fact, which I'm just telling you for intellectual amusement. A stationary population has as many individuals X years old as individuals with X years left to live. An amazing, beautiful thing. I have to skip over this because of time. I want to show you something. 2 pictures, a couple more pictures, and then I quit. We look at men and women born between 1915 and 1919. We interview them periodically in the last half of their lives. Most of them are gone now, unfortunately. We plot here the calendar year and the age for that particular cohort of people. And we plot here the number of years of life remaining to them. So if I died at age 71 in that cohort, I was born with 71 years of remaining life. And year by year, I got a year older, and my remaining life went down until finally I hit 0 and I died. So this is a lifeline, okay? And we look at the lifelines that intersect this region. And this is the region. And we plot for each box, this is age 73, 74, 75, up to 96. For each little box here, we count how many people were there in that box and what fraction of males reporting poor health in that little box. And if it's a high fraction, as many as a half, it gets a dark color. And if it's a low fraction in this box, it gets a light color. And what I want you to see here is the fraction of males reporting poor health varies along the direction of remaining years of life, but hardly varies at all along age, chronological age. That is the point of this slide. It's not how old you are, it's how long you have left to live that is associated with having self-reported poor health. Do you get this? This is an outcome of the analysis taking account of remaining years of life. Now, the death rate is going up because people die at a higher rate when they get older. But the factor associated with it is not age. What's associated with reported poor health is how long I've got left to live. Here's another example of the same. Psychological problems, people who ever had psychological problems. it's a very similar picture to reported poor health. It varies by how long I've got left to live, much more than by my age. Okay? If you take the data and you ignore this dimension, then the fraction of people who have ever had psychological problems goes up because in association with age, because age is associated with a higher death rate. So you get an artifact that looks like this, where the prevalence of psychological problems appears to increase with psychological age, with chronological age. That's an artifact. The fact is, it's not age, it's association with remaining years of life. And unfortunately, a lot of policy is made based on data like this. We've got an aging problem. I heard it yesterday during one of our speakers. He doesn't know about remaining years of life, and he doesn't know about these analyses, which are very recent. So our way of thinking about this is changing. I'm going to skip. Predictions based on chronological age patterns of healthcare expenditure overestimate total expenditure. The consequences of overestimating future morbidity prevalence range from budget misallocations to poor design of social health care systems for the elderly to lowered expectations regarding benefits of lengthened life. Well, that would be a shame if we don't appreciate that there are great benefits to longer life. What we have to do is solve the problems associated with few remaining years of life. I'm going to skip all of this to my next to last slide. Aging and senescence are not unitary. They're not one-dimensional in individuals or populations. Different multidimensional measures of aging and senescence are required for different purposes: personal, actuarial, economic, social, environmental, cultural. The future of population aging depends on how we choose to measure it. Our measurements of aging influence the actions we take to enhance healthy, active aging. And I'm going to read you 2 poems, and then I'm quit. What shall I do with this absurdity, O heart, O troubled heart, this caricature, decrepit age that has been tied to me as to a dog's tail? Never had I more excited, passionate, fantastical imagination, nor an ear and eye that more expected the impossible. People age multidimensionally. His imagination, his passion are those of a young person. His body is going in a different direction. Robert Browning, grow old along with me. The best is yet to be, the last of life for which the first was made. Thank you very much.
We'll be happy to take questions.
So I once heard it said that...
Please, use them.
I once heard it said that among the very, very, very old, they are not just the end tail of the distribution of age and death, but they are a genetic class unto themselves. Can you comment on that?
Did everybody hear the question?
Yes.
So the questioner said, I heard it said that among the very old, they are not just the tail of the distribution, they are a genetic class among themselves. It's a good question, and we don't know, but it is likely that there is selection, and that the people who reach the age of 105 or 110 may be different, because at that age, although there's a continuous increase in the rate of death per year, up to that age, the death rate stops accelerating and just remains high. Life expectancy is about 2 years from that time onward. So you have about a 50% chance of dying independent of age. So you're not senescing once you reach about 105. You're just going along with a high death rate, but a flat death rate, not an increasing death rate. That suggests that there's something to this, but we haven't, I don't know of genetic evidence that's really credible. If you know of such evidence, please send it to me, because I'd actually like to know about it. But I haven't seen that.
Anecdotal evidence is that when these people are interviewed and asked what in their lifestyle explains their old age, they typically tend to say some of them did smoke, some didn't, some exercised, some didn't, some were overweight, some didn't. But all of them say, oh, it runs in the family. My mother was like this, my siblings are like this, etc.
Yeah. So genetic components are significant, but not the whole picture. And for whatever your genetic endowment is, we know there are a number of simple things that are very important in prolonging life. One is getting a good education when you're young. 2 is exercise. 3 is sleep. 4 is not overeating. And 5 is don't poison yourself with tobacco, too much alcohol, and drugs. With these 5 things, you can control a majority of the rate of aging.
Let me ask you about this concept of OADR, of old age dependency ratio.
Yes.
You took a cut point at 65, but this could have been correct when we had to retire at that age. But now that we live longer and also are productive for longer years, maybe this should be sliding in different times, in different societies to higher values.
I agree with that 100%. And there are social problems in change. So the old age mandatory retirement in the United States was set at 65 because the life expectancy remaining at that, when Social Security was created in 1935 in the United States, remaining life expectancy was 15 years at age 65. And it's moved up, but it wasn't until about half a century later that the laws changed to move it up to 67 and 68. I was in France when the government wanted to move the mandatory age of retirement from 60 to 62, and there were riots in the streets. Thousands of people demonstrating in the streets. So there was social resistance to adaptation. So I agree with you 100%, but how to do it is another question.
Can we learn from the constant rate of young kids, like 0 to 4, that the population of the world is not going to grow without stop? I know.
So everybody heard the question. Does it mean that the population of the world will stop growing? I hope so, but it's very difficult to predict, especially the future. And it depends on what the number of children is that those young people choose to have. If they continue to have fewer on average than 2.1 children, then the population will peak and eventually actually drift downward. If they choose, my taxi driver from the airport here was one of 10 children, okay? If they go that route, which I think is very unlikely, but not humanly impossible, then we could have continuing growth. So it depends what they choose to do, and that has to do with how well we educate them, take care of their health, what alternatives we give young women to childbearing, and young men. Do men get their prestige? He told me his father wanted to have more children after 10, and his mother said, No surprise, she was doing the work. But so it depends on culture. This is not a question of demography, this is culture.
Well, we'll take one last question before I make a comment.
You may not want to answer this question, but I'm confused, frankly.
So am I. But why are you confused?
Because I tell you why I'm confused. You talk about statistics, and I assume from your remarks that this has to do with policy for community. At the same time, you introduced personal things that apply to the individual. And so there's a difference. So if you're talking about policy, then my question is, are you taking into account the behavioral changes that are taking place under our very noses? That the behavior of human beings all over the world is changing, it's an evolutionary change. And on an individual basis, you mentioned the factors that are important for individuals to know, and there was a footnote, which was a very appropriate footnote, but I'm asking about the policy now.
I think we agree, but so you're certainly right that there have been colossal behavioral changes on a global scale. In 1950, the average number of children per woman per lifetime, called the total fertility rate, the average number of children per woman per lifetime was 5. In the world today, it's 2.5. Globally. And in more than half the world, it's below 2.1, which is the replacement level. The principal exceptions to below replacement level are sub-Saharan Africa and parts of the Middle East. That's the only areas of exception. It doesn't have anything to do with religion. The Muslims, the Christians, and obviously the Jews are way ahead on this, but Muslims and Christians also coming down. The Hindus, the Buddhists, nothing to do with religion, okay? So that's a huge behavioral change. And the reason I couldn't give a definite answer to the future is precisely because it depends on future behavior. So the policy instrument is, how do we educate people? How do we provide health care? How do we take care of the people that we have? That's our lever for influencing the future. And your point is right. We need to focus on that. Thank you.
Well, thank you very much. I'd just like to make a couple of brief comments before we thank our speaker. You said briefly a comment or two ago that predictions are very difficult, especially about the future. I'm sure that was on purpose. It's attributed to many people in the past, including Groucho Marx. But I do have a tongue-in-cheek question. From one of your graphs, did I understand rightly that the way to live longer is never to complain about your health or psychological situation? That's a wonderful suggestion. Well, let's thank our speaker again. Thank you so much.